Trigonometry is the mathematics of triangles. If I draw a triangle and I call this side A and this side B and this side C, I am allowed to say A squared plus B squared is equals to C squared. I can say this using a Pythagoras theorem. So this is pi. If I choose to call this angle here theta, this is angle theta, I can say sine of theta is equals to B over C. The sine of theta is the opposite over the hypotenuse. So this is a right angle triangle. AB, C is our hypotenuse. So we can say sine theta is equals to B over C. And from there, from here, I can say that B is equals to C sine theta. This is just simple algebra. If I can also say cos of theta, the cosine of theta is equals to A over C. From here, I can say therefore A is equals to C cos theta. I can say this because I'm using Pythagoras theorem, and also because this is a right angle triangle. These trig ratios can apply, as I have just shown you. Now I want to move to the next stage. Take note of what I have here. I want to move to the next stage where I want to replace in this Pythagoras theorem expression or equation, I want to replace the B and the A with this. B is going to be replaced by C sine theta, and A is going to be replaced by C cos theta. That is the next stage. Okay, let me go there. So I'll say A squared plus B squared is equals to C squared. So where there is I am replacing A with C cos theta. I'm squaring this, plus the B is being replaced by C sine theta. This is equals to C squared. I can say this. Let me simplify the brackets. This gives me C squared cos theta squared plus C squared sine theta squared. Sine theta, no, sine theta squared, sine squared theta. This is equals to C squared. From here, I can factorize C squared. On the left hand side, I can factorize C squared. So if I factorize C squared, I will have here cos squared theta plus sine squared theta. Close the bracket. This is equals to C squared. Using the rules of algebra, I can cancel out this. If I cancel out that, I am left with cos squared theta plus sine squared theta being equals to 1. This is one of the most important trig identities that you're going to be dealing with. It is one of the basic trig identities. I used the triangle, the right angle triangle in Pythagoras theorem to show you or to prove to you that cos squared theta plus sin squared theta is equals to 1. Now we are going to derive more from this. We're going to derive more trig identities from this. Trig identities are quite powerful in mathematics. Let me rewrite this. Cos squared theta plus sine squared theta is equals to 1. Okay, there are so many trig identities that you need to know. Some of them are usually given on the formula sheet, but some of them you just have to memorize them or you have to know them. I'm just going to mention a few that are quite important. We have tan theta being equals to sin theta over cos theta. You need to know this identity, very important. We also have sec theta, which is 1 over cos theta. With these kind of identities, always look at your third letter. It tells you the ratio that you have to use, the trig ratio that you have to use. So if we have sec theta, we use cos. Then we also have cosec theta. This is 1 over sin theta. Check the third letter. It's an S, and we use the trig ratio sine. Then we have cotangent of theta, cot theta, which is 1 over tan theta. Again, the third letter gives you a hint of what to use in terms of sine, cos, and tan. You have to know these ratios. You need to know them, and you need to memorize them and to be familiar with them. Sometimes you're given on your formula sheet, sometimes you're not given. So from here, I'm going to be employing these to derive more trig identities that are quite useful in mathematics. Let me take out all of this. All right. Now I'm going to divide. Let me call this equation 1. I'm going to divide equation 1 throughout by cos squared theta. So divide by cos squared theta by cos squared theta. Throughout every term in equation 1, we are dividing it by cos squared theta. If I divide cos squared theta by cos squared theta, I get 1. If I divide sine squared theta by cos squared theta, we know that sine over cos is tan. Therefore, this will be plus tan squared theta. If I divide 1 by cos squared theta, we know that 1 over cos theta is sec theta. So this is sec squared theta. From here, I can say this is equation 2. This is equation 2, which is one of the identities that you're going to deal with. Still, I want to repeat this division in equation 1, by the way. So divide equation 1 by sine squared theta. We're dividing every term on equation 1 by sine squared theta. If I divide cos by sine, I get cot, the inverse of the tan. I get cot. So this is cot squared theta. I get cot squared theta. Cot squared theta plus 1. This is equals to, if I divide 1 by sine squared theta, I get cosec squared theta. I'm going to call this my equation 3. So I have derived 3 important equations here. With these identities, we can do a lot of things. And in trigonometry, sometimes we are required to prove identities. And we're going to rely on these nuggets that we have now. I'm going to, okay, like we're proving identities here. Proving identities. When you're proving identities, you don't come empty. You come with something. There is a lot of information that you should bring to the table. Sometimes that information is actually given to you in the question papers on a formula sheet, but sometimes you don't have the information. But even though you may have it, it requires experience. I think proving identities is more of an art than mathematics, because sometimes you take a very correct identity or an identity that is applicable. However, it will not get you to make the proof. You're going to see as I go through here. I'm going to do a few examples on proving identities. So we have this identity, prove that, prove that, prove that. Okay. The first one says sine A cot A is equals to cos A. Sine A times cot A is equals to cos A. We want to prove this. This is how you go. You take one of the sides, whether the left hand side or the right hand side, and you fix it as it is. Then you go to the other side and you manipulate it using your knowledge of identities, trig identities, and your knowledge of algebra. You manipulate it until it looks like the other side that you fixed. Sometimes you may have to manipulate both sides until they look the same so that you can show us your proof. So in this case, I'm fine with the right hand side. It's cos A. I'm going to keep it like that. So I'll say here right hand side. So this is my solution. This is what I would do if I'm working out this question. Right hand side RHS is cos A. I'm fixing this side. I'm okay with it. Then I'm going to go to my left hand side and manipulate it until it looks like the right hand side. So I have here LHS, which is my left hand side, is sine A times cot A. But I know something about cot A. Cot A is the inverse of tan. So tan is sine over cos, which means cot is cos over sine. I'm going to use that knowledge here and replace cot A with cos A over sine A. This is where I said your knowledge of other identities come when you're trying to prove identity. So from here, I can cancel out these two. Then I'm left with cos A. I've just made my left hand side look like the right hand side. So I have the proof. Then I can conclude that LHS is equals to RHS. Left hand side is equal to the right hand side. Proven. This was quite straightforward, but that is what you do in all of these identities. You just work them out in this manner. Take one of the sides, especially the one that is looking very simple. You fix it, then you go to the other side, you manipulate it using your knowledge of algebra and your knowledge of trigonometry, especially the trigonometric identities. You cancel out stuff until you have the left-hand side looking exactly the same as your right-hand side. This is one of the examples that I've just done. I'm going to do another example. It looks complicated, but it's quite straightforward. Now let me write the question. The question is prove that sine squared x, that's sine squared x plus cos squared x plus tan squared x is equals to sec squared x. They want you to prove this. It looks complicated, but it's very easy if you know your trig identities very well. If you look here, the first two terms, if we add them together, we get a 1. We have done this before. In fact, this was the first trig identity that I had to prove. So sine squared x plus cos squared x is a 1. So all this is a 1. We know that, but then let's do our proof systematically. I'm fixing my right hand side to be sec squared x. I'm fine with that. Then I go to my left hand side. I'm going to rewrite it as sine squared x plus cos squared x plus tan squared x. This is my left hand side, and I said if you look at the first two terms, they're equals to 1, so you can replace that with 1. So this is 1 plus tan squared x. We know from previously that if you add 1 plus tan squared x, the answer is sec squared x. So this is sec squared x. From here, I can conclude that my LHS is equals to my right hand side. Proven. This was quite straightforward question. I'm going to do another question that is a little bit challenging. This is a little bit challenging. This is what the question looked like. Okay, prove the trig identity that cot x plus tan x, all of this squared, is equals to cosec squared x plus sec squared x. Cosec squared x plus sec squared x. You want to prove this, that they're really equal. As I said, you choose one side to fix. I'm going to choose the right hand side. I've been choosing the right hand side. It doesn't mean that the only side you can choose. You can choose the left hand side sometimes, but with experience, you're gonna know which side to choose. Because so it's like that you don't have to spend a lot of time doing the proofs. I'm choosing the left hand side. I'm fixing my left hand, my right hand side. I mean, so RHS is equals to cosec squared x plus sec squared x. I'm fine with this. So I'm going to manipulate my left hand side so that it looks like the right hand side. Let's go. LHS is equals to cot x plus tan x squared. So we assume here that you know your algebra, you know how to expand this bracket. This is what it means. What I have here means cot x plus tan x bracket times this cot x plus tan x. This is what it means. So I'm going to expand these two brackets. If I do that, I will get cot squared x. Then if I say cot x times tan x, I'm going to add that again to itself. So I will have plus 2 tan x cot x. 2 tan x cot x. 2 tan x cot x plus tan squared x. Plus tan squared x. This is what I have. There is something that you should see here. The middle term, there is a relationship between tan x and cot x. They are inverse of the other. And we know that cot x is actually 1 over tan x. So I can write this as cot squared x plus 2 tan x times 1 over tan x plus tan squared x. If you look here, I am trying to simplify what my left hand side, which means the middle term is now essentially just a 2. I now have a 2 in the middle term. I can take out the tan x and the tan x, they're cancelling each other. I have a 2 in the middle term. Let me clear the board and continue with this question. I'm going to rewrite my right hand side, by the way. And then I write my latest left hand side. So my right hand side was cosec squared x plus sec squared x. This is my right hand side. I go to my left hand side. It was left hand side. This is how it looks now. It is cot squared x plus a 2 plus tan squared x. Alright, I know where I'm going. So whatever I'm going to be doing now is to try and create a situation that will explicitly show that the left hand side is indeed equal to the right hand side. I'm going to split the 2 in the middle into 1 plus 1. I'm allowed to do that. It's still correct mathematics. So this is cot squared x plus a 1 plus another 1. See, I just split my 2 into 1 plus 1 plus tan squared x. Now look what I have. If I take the first 2, cot squared x plus 1, that is cosec squared x. If I take the second, the last 2, it's 1 plus tan squared x. We agree that is sec squared x. We already derived these identities. We know them. And so those were given on the formula sheet. So we can conclude. So therefore, the first 2 terms can be replaced by cosec squared. So this is cosec squared x plus sec squared x. This is my left hand side. Now look at it. It looks exactly like my right hand side. So I can make the conclusion that LHS is equals to RHS. So this is a proof. Proven. It's as easy as that. But I want to reiterate that all this depends on experience. You have to really know something so that you can make these, so that you can prove these identities. You don't just come blank. You should know something. That's it. You're going to use your prior knowledge, by the way, to make these adjustments, to make these manipulations, to do these simplifications, whatever it is. There should be some knowledge that you have. So practice and practice is going to be the way out. I'm going to do one more where I'm proving an identity. One more example where I prove an identity. Prove that cot x over 1 plus cot squared x is equals to sine x cos x. Sine x cot x. Cos x, I mean. We want to prove this. I think I'm fine with my right hand side once again. I'm just going to focus on the right hand side. That is what I'm going to change to look like. So I can declare here that RHS is equal to sine x cosine of x. Done. Then I go to my right hand side, no, left hand side, I mean. Cot x over 1 plus cot squared x. Now I know something about the denominator. 1 plus cot squared x is cosec squared x. I know that is cosec squared x. So I can replace 1 plus cot squared x by cosec squared x. So now I have cot x over cosec squared x. Alright. I'm essentially here multiplying cot x by 1 over cosec squared x. That is what I'm doing. Let me continue with this. This is our left hand side. I said now we have cot x over cosec squared x, and I said this is the same as cot x times 1 over cosec squared x. All right, we know that 1 over cos is cosec, no, 1 over sine is cosec. But if we have 1 over cosec, it means that is sine. So this part here, this part is the same as sine squared x. It is sine squared x. And this part here, cot x, we know that cot x is cos over sine. So cot x is cos over sine. I'm going to use that to try and simplify this further. No one really tells you to do that. It comes from experience. It comes from your knowledge of something. So cot x is going to be cos x over the sine of x. We know this. So we're multiplying this by sine squared x. This is where we can use our algebra to cancel out. If we cancel out this, it means we're going to cancel out one of the sine here. We're going to be left with a sine x, which means our left hand side now becomes cos x sine x. This is our left hand side, which is essentially the same as our right hand side. So we can say LHS is equals to RHS. Proven. I have managed to prove all the identities that I tried. You should practice more and more of this so that you become familiar with the kind of questions that you face and the kind of algebraic manipulation that you may have to do, and the kind of like the simplification that you may have to do. All you need is to choose one of the sides, the easier one, and you keep it the way it is. Then you go to the other side and manipulate it until it looks as the other side. That is all you do when you're proving identities. Practice is what will get you there. Otherwise, thank you for watching the video. If you have any questions or any comment, just write in the comment section below. I will respond. Otherwise, thank you.